Hello, and welcome to my adaptive augmentation, intuitive robot arm programming using augmented reality presentation. What is adaptive automation? There are many meanings. One definition is both that the user and the system can create changes at an automation level. The definition of an adaptive system is set to interact entities that together can respond to changes. The relationships have changed, and many think that adaptive systems as co-workers, they think of them as friends almost, and want them to behave like humans. This presentation is about the use of a robotic arm in the automatic process with augmented reality. Intuitive robot programming. Robot programming is as hard as ever. To get robots to do their task still requires a great deal of human labor and human intelligence. Due to programming bottlenecks, engineers need to create a robot system that is more flexible and adaptable. Robots that, like humans, learn by doing. Effort is being made to transform robot programming into robot learning. What is augmented reality? Augmented reality is a technology that expands our physical world, adding layers of digital information to it. AR appears in direct view of an existing environment and adds sound, video, graphics to it. Augmented reality and robotics can be used together to form various industry sectors such as manufacturing, healthcare, and private space research. Intuitive robot programming using augmented reality simplifies and accelerates the programming process so that the necessary programming skills of employees can be reduced. So now your employees don't have to necessarily have engineering degrees. Collaborative robots enable humans and robots to work together within the same space. Robots guided by hand where points of trajectories can be stored is called kinetic teaching, meaning that if you take a robot and you hit start and you move it to a certain position and hit point 1 and hit to another position and hit point 2, that's a form of teaching that exists in robotics. Intuitive robot programming using augmented reality translates humans' action into robot programming. You program by demonstration. Another approach is using gestures. Users to generate waypoints or determining paths of the robot camera and software tools are used to interpret them. When combined with augmented reality, additional information can be given. Augmented reality and robots. Development of head-mounted displays, and I'm sure you've seen people with these big boxes on their hair, enables simplified system structure. 3D holograms can now be used in the tracking of an environment. Markers are overlaid with a virtual model that is displayed at the workstation. The gestures are recognized by the integrated cameras, and the assembly steps are thus recorded by the HoloLens. Robot training. With the help of dual neural network, robots can learn new tasks by observing and breaking down several neutral networks. The first network, known as the visual network, captures an image using the robot camera to understand the current state of an object. The other network, limitation network, tries to understand a demonstration and analyzes how an action is being performed. With this approach, robots can replicate tasks learned in training as well as perform other tasks in unprecedented scenarios. Concepts of programming. Develop an intuitive programming tool for robots. In this context, the HoloLens offers new possibilities to realize communications and information processing, which are used to develop an application that converts virtual assembly steps into a robot program. HoloLens create and generate a pick-a-place motion profiles for the robot to assemble components. Here's concepts of programming. Here's kind of a flow chart to the programming system. You have a start, you connect to the HoloLens robot, it links visual and real components, it comes up, it has a virtual assembly that you look at. From that virtual assembly, you do a type of movement and correction you want to make. It sends the coordination to the robot, and the robot picks a place and goes to the end. Concepts of programming also are markers, are used to connect images to local workspaces. In essence, some representation of a point in space. Therefore, the software development kit, such as the SKA by Vidora, is used for the HoloLens to determine the position and orientation of the component. The start and end coordinates of the assembly steps are determined and saved with respect to the internal coordinate systems of the HoloLens. Those systems are called CSH. To enable the robot to manipulate the real component, these coordinates must be transformed from the CHS, which is the HoloLens system of coordination, into a robot's base coordinate systems. So there is a difference between what is seen in the HoloLens and its system and the actual robot system. Here's a concept of the programming in a drawing of an execution, where you see a CHS system at the bottom. On the left side is the real and virtual components. The arm it receives a command based on the virtual components, and it performs the action on the right side. The interaction with the virtual objects and the control of the application is realized via the HoloLens standardized communications interface. By focus on individual objects, a user can select components and interact with them using a so-called air tap, which is the same as a mouse click. Implementation for development of HoloLens applications. Visual Studios is used in combination with Unity. The display of the project is a CAD model, and the project has to be converted into a mesh model and then imported into Unity. The CAD model of the project has to be converted to a mesh model and then imported into Unity for modification and control. Simpler applications were used in proof of concept. Locations were based on markers, when markers were detected and virtual components generated. The markers have to be fixed within the robot workspace. Accuracy and precision of marker tracking is very, very important. This was basically an experiment paper where they were experimenting with augmented reality in a automation environment. In conclusion, with the use of augmented reality, the automation of many systems that are part of the traditional automation process can change in real time. Automation using AR contributes to automation of actual procedures, including remote and robot-assisted surgeries, and can reduce injury and improve accuracy of the procedure. This paper talked about the development of an augmented reality application using Microsoft HoloLens to allow assembly of certain parts using virtual and real components in an automated workspace. Adaptive AR controls are important when it comes to increasing the automation rate in assembly tasks. Problems can be easily adjusted for errors and production issues. An additional note, AR and automation is becoming highly popular. The factories of the future are basically using AR in a lot of their machine actions. For example, I looked at a site that I saw on Amazon that showed Amazon's robotic systems in the warehouse, and they basically have a total AR and virtual reality layout of the entire warehouse, where the robots are basically programmed to perform certain tasks. Those that are doing the same continuous tasks, and then additional tasks are added. Thank you for watching my presentation. I hope you enjoyed it. It definitely was an interesting task to do. Thank you very much, and have a good one. See you later. Bye.